Well, hello, and thank you all for joining us here on the webinar today. My name is Dylan Kassane. I work with the marketing team here at Witekio, and along with our good friends from ST and Octavo, we're happy to welcome you to Leveraging Software Power on a System in Package platform. Now, we've got a packed agenda and a lot to get through today, so I'm going to kick off things with a quick introduction to our panelists, and then pass it over to them for that deep dive. So let's just jump right through into that. We've got 4 experts on the call today, one who's joining us very, very quickly at the end there, but I want to introduce you to the 3 who are going to drive things forward. First up, let me welcome Mike Hartmann, who's a product marketing manager at ST. Mike, why don't you tell the audience who you are and a little bit about ST as well?
Sure. Hi, everyone. I'm Mike Hartmann, product marketing manager for microcontrollers and microprocessors in ST's Americas region. I've been with ST for 20 years, and if you're not familiar with ST, we're an extremely large multi-billion-dollar international semiconductor manufacturer that makes products that go into anything from consumer goods, white goods, automotive, pretty much everything that has electronics in it will have ST inside of it.
Fantastic. Thanks, Mike. I'm also happy to welcome Neeraj Dantu, Applications Engineer at Octavo. Can you tell us a little about yourself and Octavo, Neeraj?
Hey, everybody. This is Neeraj Dantu. I'm an Applications Engineer for Octavo Systems. I've been with Octavo since its inception, about 6 years ago. I do, application support, reference designs, application notes, and such. Octavo is an expert in the field of system in package, which I'm going to talk about when I get the chance.
It's good to have you here. Also pleased to introduce Rafael De Cusi, an embedded software engineer here at Witekio. Rafael, pitch yourself and tell us a little bit about Witekio as well.
Okay. Hello, everyone. I'm Rafael De Cusi. I've been working for Witekio for more than 8 years now. I'm an embedded engineer specialized in low-level and middleware development. My area of expertise is the development of BSPs on different OS like Windows Embedded, Android, Microcontroller OS. But for years now, I'm mainly working on Linux and Yocto. And so Witekio is a company specialized in consulting and expertise for IoTs and embedded device. But I think Sid will be able to describe more precisely Witekio than me.
Thanks, Rafael. So let's meet Sid. Sid Nagendran, a Senior Business Development Manager here at Witekio. Sid, tell us about yourself and fill us in on the rest of the Witekio story.
Great. Thank you, Dylan. Good morning, everyone. Good evening, those dialing in from overseas. My name is Sid Nagendran, Senior Business Development Manager at Witekio. We are based out of Seattle, Washington, and our European headquarters is in France. Witekio has been serving OEMs for the past 19 years. And as Rafael mentioned, we actually we help co-pilot projects, anything from medical devices to autonomous vehicles, fitness equipment, building automation, and so forth. Yeah, we're looking forward to this webinar collaboration with ST and Octavo.
Great, thanks, Sid. The last piece of our puzzle, of course, is you, the audience. We're very happy to have you here today, too. If you've got questions during the webinar, you can add them just using the button at the bottom of your window there, and we're going to get through as many of them as we can once we get to a Q&A section at the end. So do add them as you go. We will make sure to get to as many as we can as we go. So now to get us underway, I'm going to hand over to Mike, who's going to give us a nice overview of the SM32 MP1. Mike?
Great. Sure. Thank you very much. So like Dylan said, I'll be providing an introduction to the STM32 MP1. If you're already using the STM32 MP1, great, that's awesome. If you have any more detailed questions, make sure you reach out to your local ST sales and marketing contacts and talk to them in more detail there. So as an introduction, the STM32 MP1 is a general purpose microprocessor that can address various applications, anything from industrial to medical and consumer products and home appliances. From its inception to its introduction onto the market, the MP1 was based on the strong foundation of our STM32 microcontroller products. And this includes our best-in-class support, our tools, and our ecosystem. And furthermore, ST's supply chain and our 10-year rolling longevity commitment enable you, the customers, to design our products that will have a long and successful and profitable life. The STM32 MP1's flexible architecture addresses Linux and real-time processing and includes graphics-based HMI applications. And lastly, our mainlined open ST Linux distribution and support for STM32 Cube will allow your project software development to be accelerated. And furthermore, you can leverage our authorized partners like Octavo and Witekio in our ST Partner Program to reduce your overall time to market. So perhaps you're developing or designing an advanced gateway product. Maybe it's a gateway used for home security, home control, or home automation. The STM32 MP1 can address those critical features needed for those applications. With dual Cortex A7s clocked up to 800 megahertz, the STM32 MP1 can support up to 720p HD video decode. And when using the STM32 MP157 variant with the optional 3D graphics core enabled, you can implement a high-performance graphic user interface. And lastly, the heterogeneous architecture that includes both Cortex-A and Cortex-M cores can provide the flexibility needed for various applications, including audio, voice, and other real-time processing. Perhaps your end application requires an industrial-grade processor. And of course, the STM32 MP1 can meet those needs as well. For projects requiring the industrial grade, the STM32 MP1 can support up to 125 degrees C junction temperature in 650 megahertz variants. And since the introduction of the MP1, we've taken on a lot of extensive testing targeted at industrial applications. And the results are that we can meet an industrial mission profile with 100% operating time over 10 years. When it comes to reliability and the continuity of supply, like I mentioned earlier, we have a 10-year longevity commitment. This longevity commitment is renewed every year in January, and we commit to produce the STM32 MP1 until at least January of 2031 at this point. There are ample interfaces that address industrial applications, and furthermore, real-time capability of the Cortex M4 can be leveraged in many ways. So as the world shifts to the next industrial revolution, also known as Industry 4.0, everything is connected and sharing information. And of course, the MP1 has robust features and security tools to protect any industrial product and system. So artificial intelligence is around us all these days. And so the MP1 architecture and ecosystem can enable AI capability such as image classification, voice recognition, or predictive maintenance in any end application. Perhaps you would like to add AI to your MP1 project. Since it has two different cores, there are two approaches that you can take. First, using the Cortex-A subsystem, we have support for TensorFlow Lite. This is achieved through our artificial intelligence expansion package for OpenST Linux. This package contains AI and computer vision frameworks and application examples, and further information can be found on wiki.st.com. Looking at the Cortex-M real-time subsystem, we have support for STM32 Cube.ai. It's available for many STM32 microcontrollers, and STM32 Cube.ai can also target the Cortex-M4 that's available in the MP1. STM32 Cube.ai will allow you to map and run pre-trained artificial neural networks in a real-time domain of the MP1. So one of the main points of the STM32 MP1 offering is to provide an overall system solution, not just an IC. And of course, it starts with the device, using single or dual ARM Cortex A7s, the embedded M4 microcontroller core, and the optional OpenGL 3D GPU. We have platform scalability within the family as well that I'll show on the next slide. But the device isn't much without the software, and the STM32 MP1 software environment is robust and ready for your development. We have mainlined OpenST Linux distribution, which supports the Yocto framework and other community standards. And the STM32 Cube ecosystem provides the tools and the foundations for bare metal or RTOS development. To ease your design process, you can start with the STM32 MP1 discovery or evaluation boards and reference schematics and Gerbers. There's ample documentation available on our wiki that I mentioned earlier, as well as on st.com. And you can bounce ideas off of other MP1 users in our community forums or get support directly from ST engineers using our online support system. And last but certainly not least is our valuable third-party ecosystem, with many partner companies providing services, hardware, and software to accelerate your project's development time. So now we'll take a look at the various options for the MP1. There are three main product lines, all available in 800 megahertz or 650 megahertz on the Cortex-A. The STM32 MP157 is the fully enabled variant with dual Cortex A7s, 3D GPU, DSI for display, and it also has CAN-FT for communications. The STM32 MP153 is also dual A7 with CAN-FT, giving you the performance of the MP157, but targeted at applications that don't require the 3D graphics core or the DSI LCD output. And then there's the MP151, which is a single Cortex A7. Note that all the product lines do feature the Cortex M4 for real-time operations and have an optional hardware cryptographic accelerator. So before I hand it off to my colleagues, I did wanted to give you a glimpse of what we're doing in the future for the STM32 MP general purpose microprocessor portfolio. So we have a strong MP1 offering and a strong foundation to the family. So as we look to the future, we want to focus on two main product lines. The Access line would seek to provide further cost optimizations beyond what we already have with the STM32 MP1, and also improve overall system security. And then we have our flagship line where we'll be looking to improve the performance, features, and functionality, and then, of course, improve the security. So thanks for your time today. And at this point, I'll hand it back over to Dylan for the remainder of the presentation with Niraj and Raphael.
Thanks, Mike. Certainly some food for thought there already. We've had a couple of questions come in, so that's great. If you've got questions for Mike or for any of the panelists, like I said, do add them in that box at the bottom of the screen there. We're going to get to them when we can at the end of the presentation. So to continue forward, we're going to pass over to Niraj, who's going to walk us through the advantages of the SIP. Niraj, over to you.
Thanks, Dylan. In this part of the session, we're going to talk about system in package and how it can help you accelerate your designs. This slide tells the story of semiconductor integration from when the transistor was invented through various innovations through the decades. A lot of these innovations happened because of state-of-the-art achievements in homogeneous integration, or integration on a single piece of silicon. In the past decade, we have seen a different approach: integration with silicon rather than integration on silicon, also known as heterogeneous integration. The most complex heterogeneous integration involves integrating different types of semiconductor devices, either packaged or die, electromechanical components, RF components, passives, and more, into a single device to form a system. This concept is known as a system in package. So to better understand what a system in package is, let us take a look at an example of the manufacturing process of a system in package that utilizes basic heterogeneous integration techniques. So you start with a bare die wafer from silicon manufacturers such as ST, cut it up and attach it to a substrate. This substrate can be an FR4 material, but with tight design rules going to as low as tens of microns for trace width and spacing. After the attach, die is wire bonded to the substrate. The next step is to place discrete components and go through SMT. At the end, the device is molded and balls are attached for pins. What comes out of this process is a generic BGA device that looks just like a component. So what we're doing here is taking component-level manufacturing techniques and utilizing them for system-level integration. Here's an example system in package built by Octavo. Without the mold cap on top, you can see the processor die, the power management device, packaged memory, EEPROM, and LDO, along with all the passives required on a 6-layer substrate. Octavo's newest product is the OSD32 MP15X system in package based on ST's STM32 MP15X family, which Mike talked about earlier. OSD32 MP1 integrates the STM32 MP1 processor, the ST-PMIC1, DDR3, EEPROM, oscillators, and passives in an 18mm by 18mm package. Even with all the integration in an 18mm package, OSD32MP1 exposes all the features of STM32MP1 as well as ST-PMIC1. It reduces tedious design tasks, allowing you to focus on the features that differentiate your product. It is also compatible with ST's tools and software development environments. Now let's take a look at some of the most beneficial features of OSD32MP1 in detail. There are a number of advantages of using OSD32MP1 system in package. The first and most obvious advantage is design simplification. What you see here is an example of a design using discrete components. We have the STM32MP1 connected to DDR, ST-PMIC1, and non-volatile memory as table stakes, which means every application requires these components to be connected in the right way for the design to work. Design, prototyping, testing, and verification of these so-called table stakes is necessary before you move to the application-specific design work. With system and package integration, however, this design can be simplified to this design. An OSD32MP1 based design will allow you to save significant time and effort spent in design phase. As it already integrates the PMIC and DDR, you will not have to deal with the headaches of designing the power management or the complex design challenge that is DDR interfacing and verification. Instead, the design of the power management is reduced to a single power rail input, and the DDR interfacing is completely eliminated. This allows you to focus on the functional peripherals and features that are specific to your application and differentiate your product right away at the beginning of your design. OSD32MP1 also offers functional improvements that make it easy to work with. With the optimized ball layout and 1mm pitch, you will be able to escape all the I/O of STM32MP1 in a single layer of the PCB. An example of this routing is shown here. This allows you to reduce your PCB layers and use low-cost manufacturing processes. As opposed to something like system-on modules, no special connectors or handling procedures are needed for system in package. Another advantage of using OSD32MP1 is increased reliability. The system and package integration results in better performance in every aspect of reliability compared to a discrete system, increasing the reliability of the overall system. Most common discrete failure mechanisms, such as passive cracking or SMT solder joint failure, are mitigated with ease at the system in package form factor. With design simplification also comes size reduction. OSD32 MP1 has been shown to reduce PCB area required to lay out a circuit by 60% when compared to a similar discrete design. This size reduction allows you to design smaller products for size-constrained applications or allocate the size towards a bigger battery. As it integrates over 120 components into a single device, the effort required to manage the supply chain for these components is eliminated. This is especially beneficial given the current market supply chain shortage and volatility. Along with simplification and size reduction, the overall cost of designing, producing, and maintaining the product is also reduced. The reduction in time and design effort results in significant reduction of engineering costs. Manufacturing costs are also reduced as a result of low-cost design rules, reduced layer count, and reduced size of the PCB. Assembly costs associated with the supply chain management of the integrated devices, and costs of individual device end of life are also reduced, as all of these are managed by Octavo. As a result, the total cost of ownership of the product is the lowest for OSD32 MP1 based products. Working with the OSD32 MP1 is further simplified by the hardware development tools from Octavo. We currently have 2 development boards that showcase the features of the system in package, as well as serve as a starting point for customers getting started with their designs. The OSD32 MP1 BRK is a flexible prototyping platform that exposes most of STM32 MP1 peripheral pins to its headers. It is a single-sided 4-layer design. With only about 10 components on the board, it shows how easy it is to create an embedded Linux design using OSD32 MP1. The OSD32 MP1 Red on the right is a full-featured development board with Wi-Fi, Ethernet, USB, HDMI, DSI, and headers for customization. The Red board is also a 4-layer design. Both the BRK and the Red are open source, which means you can download the design files and get started on your custom designs right away. Octavo aims to support customers in every phase of their product development. To that effect, complete data sheets, detailed application notes, open source reference designs are readily available on the website, along with active forums to answer your questions. We also have a design review service if you're interested in getting Octavo's inputs on your design. As we talked about already, OSD32 MP1 is compatible with ST's set of software development tools and its OpenST Linux distribution. In partnership with Witekio, we also developed a Debian software development kit to aid prototyping and ease software development for your product. Rafael, who's going to take it away now, is going to talk more about the Debian SDK offering.
Perfect. Thanks, Niraj. Keep those questions coming in. We've had a couple come in then while you were talking, and we are going to get to them in the Q&A. Just use the button there at the bottom of your screen. But we are going to hand over to Witekio now and to Rafael and to Sid to take us through these Debian adaptations.
Great. Thank you, Dylan. So just a quick overview on Witekio and our skill sets. As I mentioned earlier, we are a consulting company working directly with product design development companies helping them with their full stack. So that includes the kernel or the operating system, the middleware, the application, as well as cloud development. So we can help with all or any part of those layers. We work with partners to do the hardware design and development, and our involvement comes in with the software stack. And we've been doing a lot of projects on Linux-based operating systems, in particular using the Yocto framework. And in fact, that's what Raphael is going to be describing, how we have developed a Debian distribution for the Octavo SIP. And so with that, I'd like to hand it over to Raphael so she can tell you about all the different features and things that you can do with that SDK.
Thank you, Sid. So let's start first with the problem statement. When Octavo came to us a few months ago, they wanted an easy and efficient solution for embedded application in order to help the end user to prototype and develop on their board. There was already an out-of-the-box experience provided by ST, the OpenST Linux distribution based on Yocto. As a developer, I can tell you that this layer is one of the most furnished and well-documented I had the opportunity to work with, but it was not necessarily as user-friendly as Octavo wanted. They wanted something more like some other board widely used by the general public. And so the choice of Debian was pretty obvious for Octavo and for us, because Debian is one of the most famous distributions around the world, one of the first one. It's well known by Linux users. It has a long-term support. The Debian package manager is one of the best. Thousands of packages available online. It has ARM support and is compatible for IoT and embedded device. So the goal by choosing Debian was to enlarge the end user, to bring a large amount of users, even some beginners, to come and prototype on the SM32 MP1 board. So let's go back on the difference between Yocto and Debian, because that's a very important topic and interesting one. So Yocto and Debian are two completely different OS. It's based on Linux, but one is designed to be fully customizable and high performance, but it requires strong knowledge of Linux and Yocto. While the other one is designed to be general purpose, and it's simpler and user-friendly. So let's go deeper on the pros and the cons. For the system, so as I said, Yocto is designed for embedded system. It's supposed to generate an image that fits to your need, that fits to the board use case. And so you will design your image to be small, and your root file system is going to be small and efficient. Whereas on Debian, it feels and looks like a Linux desktop. It will embed tools you don't specifically need at the moment, so it will have a large root file system. For the ease of development, Yocto is difficult for beginners and even for developers. The learning curve is high, and it requires expertise on the domain. Where on Debian, it's well known by community, you will find documentation and only requires some basic Linux knowledge. For the configuration and the update, Yocto will require you to add the package you want in the image and build it manually and redeploy your image on the board if you want to do a change. There's some update mechanism that exists, but it's not by default and not easy. For the Debian, you will benefit of the package manager advantage. If you need any tools, you just have to type apt-get install the name of the tool, and all the dependency will be taken care of by the package manager. So that's easy and on the go. If you need any tool to test your application, and if you're missing one tool, you can download it. For the build, since Yocto is highly customizable, all the component sources need to be built. Yocto download all the sources and you will need to rebuild everything. So builds, depending on what you want and depending of the type of your machine, can take up to hours. I can tell you if you want Qt and Qt Web Engine, it can take you the afternoon. For the build of Debian, the distribution components are already prepackaged, so the image is easy and fast to build. For the component customization, this is one of the strengths of Yocto. Yocto is #1 on that. You can customize and patch everything since you have the sources of every components of your system. You can read those sources and do every modification you want to and apply those patch on your Yocto layer. Whereas on Debian, you will need to create your own Debian package and take care of the update manager. So after all those pros and cons, Octavo wanted to focus on the ease of development and on the system, something that could bring a large audience, and wanted to stay as user-friendly as possible, so the choice of Debian has been made. So now let's talk about the solution Witekio put in place. The best way to describe this solution is to keep it simple by showing only 4 blocks. Those 4 blocks represent the SDK all-in-one we provided. It will let you access and download the sources, set up the architecture of your project and the environment, build your root file system, generate the image, and provide tools for the flashing of the SD card or the internal memory. So for the 4 blocks, we are using a Git repo to download only one manifest that will come and grabs all the repositories we need for the build of our SDK, some ST repositories or some Octavo repositories. All you have to do is to type one command line, you will download the manifest, and after you will just have to run some scripts. For the environment, we are using Docker. Docker Container Image is a lightweight standalone that includes everything you need for a self-contained environment. Code, runtime, libraries. It's light and it's running on top of your operating system. It's not a virtual machine. Virtual machine could do the same, but it's way too heavy for the need we have. So we wanted just to contain every tools we needed to be able to build the SDK. The first good point of that is it doesn't mess with your development environment. As a developer, I don't want to have to change my alternative, download a specific version of Python or some cross tool chains. I don't want to mess my environment, my Linux. So with that, you will just download the container and you will run it, and it will be totally transparent on your OS. It also removed it works on my machine. Like I am able to build the SDK, but someone cannot because of his computer is Windows or Linux, and we don't know why. So the build is reproducible with Docker. All it costs is to install Docker. So yeah, we have to install something, but Docker is widely used, and this is something you will need on your computer in the future. So you install Docker and you build only once the Docker image, and after that you can run any software or SDK without any missing tools, libraries, or conversion. Talking about Docker, we embed a tool called Multistrap. This is what we are using to generate the root file system. So you can see on top a small configuration file. I keep it simple for the demo, but the real one is a little bit more complex. This file is used by Multistrap to generate your root file system, in our case, ARM root file system, and all the dependencies are taken care of by Multistrap. So it's pretty simple to fill. You have few fields important the architecture, so we choose ARM, the suite of the Debian we wanted Buster. For the source, this is where the package of Debian are hosted, the one we want, the keyring, because every Debian package are signed, and the field packages, where you put every packages you want. Here I put only 2 packages for the demo, but the Octavo one is way more complex. And now I'm going to present you the custom build package we created. It's a set of scripts that comes and configure, patch, and build every binaries we need for the system. The system that will run on your board, you have a layout on this slide, the system layout. We try to fit exactly with the one provided by ST because we wanted to make it compliant and do not lose developer used to work on the ST MP1 dev kit. So this is the same layout. You can see 4 partitions: the boot file system, root file system, user and vendor file system. The boot file system contains most of the work we have done on this project. This is not the topic of today, but it contains the board support package we have done. The red board is pretty similar to a dev kit from ST, the MP1 dev kit, but it's not totally the same. So we had to patch the bootloader, the kernel, the device tree, and also the X-Linux files to make it custom for the OSD32 MP1. So the boot file system will start the board and boot until you can access to a root file system. The root file system has been generated by Multistrap. It contains some ST important files, some drivers like the user and the vendor FS. It also contains some Octavo extra files, for example, some configuration files, or since we are embedding some Bluetooth, we need specific firmwares for that. So it will copy and embed firmwares we need for the red board. And also we wanted to put a simple layer of customization for the end user. We created a directory where the end user can put all the files he wants by default on the board, and it's going to be copied and embedded in the image. So for the image generation, we are generating a binary. The Docker also embeds every tools you need to be able to deploy on the OSD32 MP1 red board. So all you need is to type a simple command. You do a make build all, and you will generate your image, and after you just have to flash. And to conclude the presentation, I'm gonna talk about the overall outcome. A few weeks ago, I had the opportunity to talk with Niraj and have some feedback. So the feedback was good for customers. Octavo SIP has been able to appeal a wider audience with their new design, providing a simple SDK but feature-rich. The feedbacks has been good so far. It has been easy to work with. Only few issues has been reported and were easy to fix. And the most important, we reached our goal because customers say they choose Octavo's solution over another because it had support for Debian. So the SDK is here, it's ready to go, waiting for you, and thank you.
Fantastic. Thanks, Raphael, and thanks, Sid, as well. We're going to jump into some questions here, and a lot have come in. I'm going to get to those in just a second, but first, we're going to put a question to you, and I'll put it to the rest of the panel as well. Let me just push it out, and we'll publish this as a poll there. You should see a poll jump up down on your screen. If you jump in and submit your vote, we're trying to find out what operating system you might plan to use once you start your development. And maybe just while we're doing that, Raphael, if you can just jump in. You mentioned some advantages there for Octavo of using Debian over OpenST Linux. Are you seeing some of these other operating systems as well?
Can you repeat? Sorry.
Are you seeing people also working with outside of Linux, outside of Debian with Android, for example?
Yes, but it's the most common project we have we had on Debian and on Linux in general. You will choose an Android because you want the graphical stack and you want the, if you do not choose to design your own application, like, a Qt application running on top of a really small system, and if you want a rich feature OS, you will choose Android. For something else, we can talk about some microcontroller OS, but here, if we are talking about microprocessor, generally we're choosing Android, Linux, or also Windows Embedded, but now Windows Embedded it's less popular now.
It certainly seems that way. The split is fairly even here between OpenST Linux and Debian. Nobody seems very interested in using any of the others right now, but it's not to say that they can't. Mike, I've got a question that came in for you quite early. And I'd like to just get your thoughts on that. You mentioned a couple of times the 10-year longevity guarantee.
Yes.
Why is that actually important for device vendors?
So what we see is, especially in the industrial market space, there's going to be customers of ours, the equipment manufacturers that are going to want to be able to supply it to to their end industrial customers for a very long period of time. And so, other microprocessor devices that might be more consumer focused are going to have a rapid design cycle where, like with your cell phones, just as an example, there's new microprocessors going into your cell phones being developed pretty much every probably 12 to 18 months. Whereas in the industrial segment, you're going to see a very long lifespan because they want to have continuity of supply. And it's just a lot easier to support these large, manufacturing industrial customers. And so, we mirror our supply off of what the needs of our customers are. And so to be able to supply an identical device, the device for 10 years and longer, it is definitely something that's required by our customer base. And we've done it from pretty much day one with our STM32 microcontrollers. So the first STM32 microcontroller was, designed in probably 05, 06 area and hit the market in 07. And we just re-upped the 10-year longevity commitment for that. So that one microcontroller device that you could buy in 2007, you'll still be able to buy in 2031. So you don't have to be redesigning your products over and over again, just based on the semiconductor supply.
Perfect.
Hope that answers the question.
I think it's really clear. Thanks. Niraj, we had a question regarding the OSD32 MP1. Will there be when will the 800 megahertz version be available?
I believe it's already available now. I would advise you to contact sales@octavosystems.com to purchase our samples.
And just in relation to samples, we had another question come in asking whether it's possible to get some OSD31 MP1 samples. Would they go through you or someone else?
Yep, the samples are available on our distributors, DigiKey, Mouser, and they can also contact us directly at sales@octavosystems.com.
In terms of in capabilities, and I'll just stay with you, Niraj, for a minute there. Do you envision integrating the Ethernet physical layer there, the PHY?
Integration is always an interesting question. The choice of integrating the PMIC and the DDR were obvious because they go in every system, but something like an Ethernet PHY is more of a choice, as you have a lot of Ethernet PHYs out there, and some people choose Wi-Fi over Ethernet, for example. So it's not out of the question. We have released several variants of system in packages that we have before, and we're always looking for suggestions and where the market demand is on various things to integrate.
That's great. Raphael, I think this one is for you. For both Yocto and Debian, do you need a Linux system to do the development, or can someone use Windows like WSL2, for example?
For Yocto, it depends. It depends on how you will set your environment. In our case, since we are using Docker, it should work on Windows. I say that it should work because I had the opportunity to test it, but normally it can run on top of Windows.
Okay. Niraj, back to you, I think. Will the Octavo Debian Docker SDK cover the OSD32 MP1 BRK?
Yes, that is the plan right now. We are going to add support. We just added support for Yocto for the BRK as well. We're working on upgrading the Debian SDK as well as adding more boards to the distribution as well.
Perfect. I think this will be for you, Raphael, and maybe Niraj. Do you support ST-Cube device tree generation files?
Yes and no. The Octavo board currently need a specific configuration for the PLL of the Ethernet. The ST-Cube device regeneration doesn't let us to configure correctly this lock, and we had to change it manually. So we can generate like 99% of the device tree, but we have to do some change manually for the set of the Ethernet clock.
I can jump in as well. Cube MX generation tools are compatible with OSD32 MP1 devices, specifically for the Red board as well.
Yes, for the Red board.
We have a minimal Cube MX project that we have available on our website in one of our application notes that you can use to get started with the device itself. And as well, if you look at the device trees that are generated by CubeMX, in general, you have to work to add a lot of user sections. In other words, you have to add in sections that you need to, because the tool can only get you, so far. So yeah, I would say it is compatible.
That's great. I'm going to just push another poll now to the audience here. I've got another couple of questions on a different topic, but let me push this one to you here. What's the hardest part of adopting a microprocessor-based system? If you can just jump in and answer that one there, you've got a few choices. The power supply design and sequencing, the DDR and high-speed design, embedded Linux development and customization, tool chains and support, or something else. And if it's something else, be sure and drop us a note in the chat of what we should be concerned about there. Let's just give people a second to answer that one there. It looks early on like DDR and high-speed design is where the issues are going to be. Raphael, you're nodding your head. This is no surprise.
Yes.
Yeah, I'll just jump in quickly because I get to see all the MP1 customers throughout the Americas region, both North and South and Central America, and the number of customers that kind of did their first design and they did it alone without reaching out for any support from ST or from our partners. They do board spins and more board spins, and so it's always a little disheartening when you engage with the customer and they're just like, oh, we're on our third board spin already. We wish we would have reached out to you a little bit sooner or engaged with a company like Octavo. It's always better to ask early and not spend the time and the money on the board spin. So it's not a shock that DDR is up there pretty high.
Niraj, we've got a question here about the developer package patch from Octavo for OpenST Linux. It's currently version 2.4, the SDK, which has the Linux kernel of 5.4. When will the patch for version 3 SDK for Linux kernel 5.10.10 come through?
As I said earlier, we just released the V3.0 support for BRK. It is, quite easy to generate the extract patches from there as well. But we are working on releasing the developer package patches as well as images that are compatible with the v3.0 OpenST Linux as well. So that's coming momentarily.
That sounds great. Niraj, we've got a question, and it's going to bounce a little bit off something you mentioned during your presentation, but Mike, I think I'll bring it over to you as well. Niraj, you mentioned supply chain challenges and how this was something that a system in package could help address. Supply chain's obviously in the news right now. We're probably going to be looking forward to months of supply chain news. Is system in a package a way to really reduce that risk for customers? And I guess the second question is, how is Octavo dealing with this supply chain challenge that's right across the board?
To that first question, absolutely yes. System in package is a great solution to make it easier for customers to reduce their supply chain burden. And especially in environments like this, it's very important that you make sure you have the volume to build your own products. So definitely, because we work so closely with our manufacturing partners, ST and silicon providers like ST, it is possible for us to be able to navigate this difficult times, more easily than a lot of smaller players.
And Mike, I guess for ST, I mean, everybody's facing supply challenges now. How are you coping there?
Well, yeah. So we're doing the best we can. There's when the demand exceeds the capacity, it's it's a challenge for everyone, and we're I think us as well as everyone else in the industry is doing the best that we can. But I think just to kind of add on to what Niraj was saying, the benefits of the SIP is, he explained in his presentation, they're getting raw die from us. So when you think about, there's capacity at the wafer fabrication level, and then there's capacity at the packaging level, and so they're actually removing us packaging the silicon itself. So they're taking raw die from us. And therefore, they're able to get it sooner in the entire manufacturing flow, which makes the entire process more efficient. So, that's one thing where partners like Octavo can really help the customer in the overall supply chain side of things, make things more efficient.
That's great. We've moved through just about all of our questions here. If you've got a final question, we might just have time to squeeze it in. So I'm just going to give you a second to do that. Otherwise, we'll move just to the end here. It looks like we're coming up on time, and we're also answered just about all of those questions there, so that's great. I want to thank everybody for their time and for participating today. Certainly our guests, Mike, Niraj, Rafael, and Sid, thank you for participating. Thank you for answering the questions. Of course, we have your contact details, and if you're going to reach out afterwards, if you'd like to talk to someone, we'll be sure to be able to connect you with ST, with Octavo, or with the people at Witekio as well. Certainly, thanks to our audience for joining us today too, and for your participation in our polls and with your questions. We'll be reaching out in the next day or so with a link to the replay of the webinar. You can share that around with your colleagues who weren't able to make it today, and check out the replay and all of the information. It's got all of the information in that email as well about how to reach Octavo, how to reach ST, and how to reach us here at Witekio. Thank you so much for your participation, for your attendance. We look forward to seeing you at our next event. And from us here at Witekio, thank you, and have a very good rest of your day.